Hey everybody, welcome to 100% Builders with Jam.dev. Today we have Abhishek Tayal as our guest. He is a senior engineering manager at Pinterest working on serving and the retrieval infrastructure. And Abhishek is also an OG machine learning engineer. And that's why we're really excited to chat with him today. He has been working on machine learning and artificial intelligence before it was cool. So we're really, really excited to have you here, Abhishek.
Thank you. Yeah, super pumped. Really looking forward to all that we get to talk about.
Abhishek, you've been in this space for so long and have been building recommendation systems forever. What's got you excited these days?
Yeah, these days, it kind of in the last few months, I think with LLMs and all the talk around that heating up, I think at the application layer of there's a very critical component, which is the vector DBs. And so some backstory on that, we started building that at Twitter in my team about 5 years or so back, vector DB, some form of that. And we were very early, at least in terms of what was publicly known. I'm sure, some other companies like Facebook and or Meta and Google are doing something around that. And so we took a really early stance in some of this. We were doing a lot of research at the time. There were some algorithms which are core to building vector DBs. I think one of them is called HNSW, which is now kind of the algorithm that is run on almost all vector DB solutions. And we went with that at that time, publicly it was not something that was known that could become really the thing later on. And now it's been interesting to see how the industry has evolved. It's a cool thing now. It's a critical part of the LLM infrastructure or any most generative AI infrastructure. And it's been interesting to see the evolution of that technology with still that algorithm that we actually also went with our doubts in mind, being, in our own minds, being one of the first few people to go this route. And so it's gratifying in some sense that, that's where the industry went also. So it gives you, you can have a pat on the back. Okay, we were making the right decisions in a small team of 2-3 people doing this for the first time. And then most of the industry is going there. If you see likes of whatever is available out there, Pinecone or BB8 or Vespa or whatnot, everyone picked this. So that's interesting. That's where I'm keeping a lot of tabs on. It is critical to, tackling a lot of things on the generative infrastructure, like healing hallucinations and whatnot. Just the last week, I was on the panel for Pinecone conferences where they were talking about just like touching this stuff. So that's been top of mind. It's been an interesting thing looking back.
So Abhishek, one of the things that you mentioned was when you were at Twitter, like you were sort of one of the early people to work on like vector databases. I think a lot of our listeners who are like engineers who are working in generative AI or thinking about moving there, they're seeing this term a lot, like vector databases. Of course, like Pinecone is working on it. But what does that actually mean? And like, why should they care? Like, why not use like the layman engineer in me would say, why not just use like a regular like SQL database? Like, why use vector DB?
Yeah, great question. So actually, I'll break it down in like few different ways. The first thing we have to understand before even we go to vector DBs is kind of the advent of things like representation learning. What that means is, are you able to encode the whole knowledge base in what is called embeddings, right? So the way you typically do that, let's say we can take an example. You're dealing with some form of content, whether it could be tweets, videos, it could be pins, whatnot. Now, you have to find a way to encode your whole, I'm calling this the content space or the user space in some form, which makes it easy to ask different kind of questions about that knowledge base, right? So it could be, for example, I have a tweet, tell me in some semantic sense, what are the 10 other most similar tweets to this tweet, right? So that's what representation learning or embeddings enable at their core. They're embedding knowledge in some sort of a vector representation. And there are a few things about that vector representation, which is that it enables you to ask all these kind of questions. It has guarantees that neighbors of a particular vector are going to be similar to the one that you sent as a query. Now, there's a lot of things that go into learning that space, which is where a lot of the magic lies of learning semantic meaning, which was not possible even maybe 5-7 years ago when deep learning was not a thing. It was a hard thing, right? So at the core, that is what is enabled from representation learning. Now, when you think of the scale of these things, you're really talking about, if you're thinking about tweets or pins or whatever, you're almost talking about billions. Now, when you're thinking about, okay, in the simplest terms, I send you a vector. You're asking me to give me the closest 10 vectors. How would you do it as, CS 101 solution? You would take the dot product of this query vector with the billion other vectors and sort them and send you the top 10. But is that doable when you really need to do this multiple times on every page refresh at Twitter or Pinterest? Not doable. So that's where vector DBs come in. All that they're trying to do is help you scale these kind of functionality, this kind of a query pattern. And the way they do that is that they are not taking dot products in billions. They are huge. This is a huge space. There are a lot of algorithms in this, and each has a different way of smartly doing this, but they're avoiding those billion computation. And they're trading off what is called recall, meaning if you were to ask me top 10, I will likely give you maybe the top 8 and miss on the 2, right? Maybe they're from the top 20, 30, 40, but now you can get the result back in milliseconds versus if you were to do billion computation, billion dot products and sort them.
So basically, it's like you're making a trade-off here, like where in the traditional databases, you would have to, it will be accurate, but it's going to take a long time, right? But in the vector database space, you will be able to retrieve those queries like in milliseconds, but it might not be super accurate. But in this case, you probably don't care.
You don't really care because in most of your AI stack, this is just one component and there's things that happen after that, and you can correct for this in different ways, and so forth. And if I were to add to that, that's just like, this is just one component of VectorDB. Now you get into an interesting space that, okay, you want the nearest neighbors, let's say, but then beyond that, you have some, keywords that you also want to filter on at the same time. So what you're really saying is, give me these 10 nearest neighbors, but make sure they are all wearing a hat. Let me say that, right? Or whatever. So you also need some strong guarantees, or you're saying, okay, this is the color or this is the language that I want in. So you have two options. Either you can encode that in the embedding space itself, which based on the application can be really tough to do for a lot of the applications. So you push that complexity also down to the database itself, meaning that the application can ask you, okay, filter on these 5 things, but make sure they are the nearest 5 things with these filters. And so now that gets really complex. You're still trying to serve this in milliseconds. You're still trying to deal with, billions. So that's where kind of the intersection of vector DBs with the traditional search infrastructure or, Lucene and Elasticsearch, all those things start to come in. And that's where this space has kind of really, come into a lot of the limelight.
Why are there so many vector DB companies? Like, what's the main debate in this space? When you talk to insiders, engineers working on vector DBs, what are they debating? Like, what's...
Yeah. So I think it being a developer product, I think a lot of times, the first thing starts to come in even before, let's say, talk about application engineers. What do they care about? It's like, tell me what will take the least amount of time so that I can roll this application out. So there's a lot of that in the space of people who are just trying to use this as one of those tools who are not too familiar or are not, bothered about all of the complexities that it can bring in 1 year from now as their application evolves. For them, a lot of the, worries, okay, what can help me do this the fastest? So that's why you see, the likes of Chroma and those things emerge, which are, okay, very simple APIs in Python, the go-to language for a lot of the application developers. So it helps them get hooked in, matter of hours. As a matter of fact, like I was doing a hack week at Pinterest just a couple of weeks back, I mean, that was the simplest thing. It was, already integrated with LangChain. So why not? This is at the same time when one of my teams actually runs a vector DB at Pinterest. Like we have our own, but that's like a large scale system. Takes some time to get hooked up, etc. So that's why you see a lot of these new coming in. And I think I saw something just the last week also. There was another person who kind of just hooked it up, one of the algorithms underneath, and gave it a very simple Python API. So, so there are a lot of these, just developer focused solutions. And those are not necessarily at the moment thinking about what happens when this goes to billion. They're thinking about in memory, easy to integrate solutions. Um, Now, what happens when it goes to billions? It becomes a beast of the system. And so, a lot of these companies, I think Vespa was very early on this, and Pinecone, they started this 3 years back. So they were somewhat early in the sense. So they were targeting a very niche sort of developer market in machine learning engineers or people who really understood the scale or that, and they were, really considerate and taking the right step, choosing the right offering. So they were approaching it from that point of view. And there are a bunch of them in the space. I think underlying most of them, you see the same algorithms, largely the same algorithm space, if not exactly the same one. Um, there's an open source offering that exists from Meta for a good, I think 5 6 years. It's called Files. If you go to that thing, it gives you maybe, I don't know, tens of algorithms. All of them are there for you to use. It takes 2 days to just set it up because it has some like interesting dependencies. But then you don't know which one to use. There's no golden cave path for what's the right thing given my application or what's not. So that's kind of the space. And recently, interesting fact, we never used to call this vector DBs. We always used to call it approximate nearest neighbors. I think that's that's how literature talks about it, like all along. I don't know what led to it started to call vector DBs, because maybe it starts to look like a major market, because the moment you attach DB to it, it starts to become like a big TAM opportunity. And that's when now you have any company who is a DB till this date also wants a vector DB solution on top. So there's a race on that. Now you have Databricks, now you have Redis, now you have, I think almost everyone who had a DB in their name will try to probably put out a solution which has vector as a prefix as well. Right? So not all of them will have the right underlying, um, you know, infrastructure. So things like Redis, they're key value stored in nature, but they're adding layers to make it somehow work in a vector DB space. But that's, I think, a hard thing to do. You're kind of making post fixes just to kind of stay relevant in the market on what's hot. And maybe they'll be able to cross sell with some of their customers. But eventually, I think either my hot take on this would be either companies or solutions which were solving the search space, like the search infrastructure space. So the likes of Elasticsearch, Lucene, or even things like Vespa, who are built with kind of search use case as in their mind, and then adding vector DB solutions on top will kind of start to lead the space. So Elasticsearch just yesterday, I think, also launched something. They were really behind, but I don't know for what reason. They never got into this, but now they are also trying to get into this. So my take would be that those will be the kind of existing solutions that start to win. Um, as an corollary, Adprint is the team that actually runs the vector DB. So we, for context, run one of the biggest vector DBs, and we've been running it for like 3 4 years now. It's on the billion scale for some use cases. We run close to 30 40 clusters for this. And the team that does it is actually also the team that builds the search infrastructure, and is very closely, the two things are very closely integrated because of the reason I talked about earlier, that you need to have filters on top of your nearest neighbor query. So these two things need to really sit together and work well.
We want to go back a little bit here. So Abhishek, you're one of the experts in like recommendation systems. When I was in college, I took an information retrieval class, and one of the things that they taught us was most recommendation systems, at least back then, was based on like TF-IDF, which is like, how frequently a text appears and how infrequently it appears in the general like corpus. And then after that, like a few years later, I read this, like I think it was a pretty famous blog post by Netflix on like collaborative filtering, where they would like the underlying idea was showing you the movies that you will like that are similar to other people who like the same movies and basically recommending the same movies to you. Like how has it changed since then? Because you were in like around like 2012, 15, around that time, you were working at Amazon. I think you were working on the Amazon Prime Video recommendation system. Like, so you've seen some of those like early details. Like, how did that change? What are things that are still the same?
Yeah, very interesting question, actually. Yeah, so as a matter of fact, in 2012, when we were building this for Amazon, we were basically doing that because, you know, AI was not a thing back then. ML was a not new nomenclature, starting to get introduced at the time. So we were doing exactly that. We were doing matrix factorization, which is essentially trying to do collaborative filtering and, recommend you things that other similar people have watched. Now, it has kind of just exploded from the, I'll not even talk about how the whole nomenclature has evolved to make it sound very, 2070 or something. But there have been incremental steps along multiple different dimensions. Um, it'd be remiss if I were to not talk about, just totally focus on, the models or the ML part of it and not talk about the infrastructure that enables all of this and how that has kind of really drastically evolved since then. So, in what I'm talking about there is back then we were doing this, we didn't necessarily have even, a good working Hadoop cluster for ourselves. Some teams at Amazon did, like the teams that were doing, people who bought this also bought for e-commerce website because, that was one of the key things. They had a Hadoop cluster. They kind of hand wrote this whole thing in Hadoop at somewhat of a large scale, which was already kind of quite wondrous at the time when we were talking to them. For us, we didn't have a working Hadoop solution, so we were really doing it in memory using scikit-learn. Try to do this for all of that, and then from there on, we kind of had to build our own kind of handcrafted infrastructure that would actually make these recommendations serve to the end user.
Wait, so I want to interrupt you for a second. So, like you're doing this like in memory using scikit. That means every time the system like restarts or it like spins up in different machine, you're basically like losing that, right?
No. So, yeah. So I probably can clarify. So the training was happening as scikit-learn, but then the rest of the infrastructure was like, okay, we were pushing. So again, in collaborative filtering, you get two sides. It's still embeddings back then, right? It's just not no deep learning. From collaborative filtering, we're still getting embeddings for each of the movies and each of the users. So what we were doing was we were pushing the embedding for users in a key value store, and we were pushing embeddings for each of the movies in actually what was the AWS solution for Elasticsearch at the time. So very early on, we were doing essentially embedding lookups. We actually had these keywords also indexed in that Elasticsearch solution, um, which were essentially things like, okay, what is the genre of the movie? Who are the directors of the movie? What is the language of the movie and stuff like that. And we were doing the very same thing, what vector DBs are common like now at a much bigger scale, at a much more complex thing, which was, okay, the underlying model is collaborative filtering and metrics factorization, but the serving path looked somewhat very similar. So I think this was quite ahead of the time. It took us almost, I think, an year to get out the first iteration of it because we were building everything from scratch. There was nothing that existed. At the time, also got lucky. So I didn't have any machine learning background at the time. I was more by education, distributed systems and all of that stuff. And so that's what I was providing to the team. And very intriguingly, learning from a bunch of professors, which Amazon decided to get into Amazon and make this as their first testing grounds because ML was starting to talk around and Amazon didn't want to kind of miss on that. So this was an early experiment. I was just lucky to be in the middle of that as a new grad at Amazon at the time. So I kind of got to work on something that would stay for years to come.
Yeah, and Abhishek, back then, like when you were saying like hiring professors, like you said, machine learning was not really a popular term. It was mostly hiring professors who are doing probably data mining or like information retrieval.
Yeah, yeah, stats, some form of stats in different forms. They just hired them. They said, okay, let's see what happened. And even every small thing that they did, I think they did a couple more things outside of this, uh, led to huge gains with minimal investments at the time outside of, these small research groups. And so I think this was Amazon trying to test waters at the same time. They hired some multiple groups in parallel. Most of these groups were success, and so I think that was Amazon's start on that. I was just lucky to be in the right place at the right time, contributing my skills, but learning a heck lot from those people in the early days.
For the people listening, what are all the recommendation systems that they probably use on a daily, weekly, monthly cadence that you worked on building?
Yeah. So I think starting from Amazon Prime Video, actually, interesting fact in 2012, no one knew what Amazon Prime Video was. At the time of joining, I didn't know what that was. It sounded interesting. So I just ended up joining. When I would interview folks for the team, I quite vividly remember for a good 1 year or 18 months, explain them what is this, what we are doing. So I would basically tell them we are trying to build like a kind of an experience because they would relate that to that, quite fast. So that was, yeah, just a digression, but that was how early Prime Video was. At the time, I think we were 30 engineers or so. I think now they're probably on the thousands. So that was that. Then from there, I joined an ad tech startup called Teleport. This was acquired, another interesting fact, on my 10th day into the company by Twitter. So all that dream of being in a startup and doing startup things kind of ended there. Um, so I went into Twitter. The interesting thing, though, that was it continued to operate as a separate business and as a separate team for good 12, 18 months. So I kind of got the opportunity to live the startup life without being in a startup and having a brand name step on that. So not too bad of a deal, I guess. And after that, I worked with Twitter ads for about another 12, 18 months. And then I think this was really critical as I look back. Deep learning was starting to kick off at the time. Twitter had acquired a deep learning startup uh, right around that time. They were about an year into the company, and we were seeing some early work that they had done and brought to the product. Earlier, it was, I think, mostly focused on some video applications of deep learning, which is what the startup was doing early on. And then I just transitioned into that team. That was, I thought, this thing is picking up. I really need to know and understand what this is. I had learned from a previous experience. I had seen what the value of, keeping ahead on the technology train feels like. And I really, really enjoyed that, that ambiguity of you're kind of figuring things out as you go. There's not a set golden path laid out there. And so you're not just going and executing, there's a lot of figuring out that is involved. So I joined um, this, this team, which then basically became their, uh, you can think of as ML infrastructure or deep learning infrastructure. So we were building ML deep learning infrastructure for the rest of Twitter. So as I started to do that, and this was basically everything at Twitter, from home feed recommendation to ads to whatnot. We were providing the building blocks then that everyone else would build on them. From there, I think good 6, 8 months in, I started an effort, which was just me at the time. Then one more person joined, which was essentially, okay, deep learning is here. We have some experiences that are powering this, which was like, okay, simple deep learning models, which are already quite promising. And we wanted to see, okay, what's the next thing that this enables? And so it was representation learning and, can we learn embeddings for our content? That's where it started as a thought in one of an offsites that we had. It was a very early kind of just seed that was put in. Okay, what would that look like if you were to learn embeddings for all tweets, all users, and stuff like that? And so started to build a team from 1 to 2 to 3. And at the end of it, when I left Twitter, we were about 7 or 8, not too big of a team. But what we did at the time, we didn't realize that we were kind of deep into something that would kind of become, um, de facto relevance or recommendation system stack at every place. I don't want to claim that we kind of invented it. It was, I think the inspiration there was from one of early works from YouTube. So YouTube started doing this, I think back in 2014 or 15, and they had a paper back then, which was, okay, you can learn embeddings, and that's how you change your retrieval stack. Retrieval meaning information retrieval for recommendations. Uh, till then, it was deep learning and machine learning had started to make its impact on the ranking layer. So if you have to think about recommendation stack, there's a retrieval layer in which, so I'm just kind of a digression so that people have the right context. In the recommendation stack, you're going from billion in some cases to a few thousands in the first step of your recommendation funnel. So given a user, all these billion tweets are pinned for the context, meaning for the surface or for the query. First, select a few thousand from all these billions, and that's retrieval or candidate generation, right? And from there, you go on to ranking the thousands that you have, because you cannot rank billions. It's already, you know, it's it's not possible both in terms of cost or latency. So you have to first have that step. And then most of the impact of deep learning or machine learning was happening at the ranking layer, because these models you can make them really heavy, very parameterized and smart. And they would do a great job of picking the best 10 from thousands or best 20 from thousands that you're giving it. Right. So that's where most of the impact of machine learning or deep learning was. This work from YouTube, and the first author is Zia Adams. He's right now at Pinterest. Amazing guy. He was just check for him. They proposed at YouTube that you can actually change the retrieval stack to not have the heuristics. So in doing so, from going to billions to thousands, what you would typically do is you have your information retrieval engine. So you would create hand curated, rules or retrieval queries based on what you know about your application. So if I'm recommending movies, I would say, okay, given you have seen 2 action movies in the past, maybe give me the 10 most popular action movies from the last week. Or I will create combination of these rules and create those queries, with some domain expertise, and then send it to the engine. And so this whole process was very manual, cumbersome. Each iteration would be like, okay, what's the next best idea in different directions? There was no incrementality to it. And it would either be a hit or a miss based on how much domain expertise you have. And so iteration or innovation in that layer was hard. With this approach, it was basically bringing in machine learning to this layer in a very principled way. You could learn models which was optimized for the same business metrics that you were optimizing for at the ranking layer, for example, engagement or whatnot, right? And the end product would be that you're learning embeddings. Those embeddings are optimized for your business objectives. You're putting them in your vector DBs, you're querying them, and there you go. You have now a system which can really start to get, improved with more data, better modeling techniques. And so you set up the foundation of a system which has incrementality built into it by design. So that starts to kind of really power how fast your recommendation system in that way can improve.
You bring up optimizing for business objectives. How does that work on all these teams? Like, do you have a product manager? Like, what are the product requirements of a recommendation system? How do you know if you're making the recommendations better or worse? Like, what are you all doing on those teams?
I hope there was like a simple answer to this, but it kind of involves so many moving pieces as well and players. So from the point of view of a product manager, you always have some top line business metrics that you feel are the right ones that align with your, let's say, whatever with a company financials or what growth that company looks like, or what a healthy product looks like. So it could be things like BAU, MAU, or whatnot, right? So that's your North Star in most of these cases. Then you take a step back from that. That's not something that you can directly put into a model and optimize for. So you would typically have some surrogates or proxies as to what approximates this final business goal the best. So in most of these, social media companies, it would be something like, okay, a like or a retweet, right? In Amazon Video, it would be the watch time, for example, right? Because the more you're watching, the likely you're coming back to the platform and stuff like that. Now, the interesting thing is there's not one proxy. There are many, most often, right? So what you're doing is you're trying to optimize for all of them, but then through experimentation, you're trying to figure out what's the best combination of these proxies. That's the best that moves this business metric in the most reliable way. So there's no formula to that. There's no product manager who can come up with a formula for that. That's purely derived from experimentation. And then these are things that you can put in your models.
You know, like something that you said earlier, we have a lot of listeners who are engineers, and like everyone would a lot of people would like to work on like the bleeding edge machine learning stuff and the AI stuff. But the truth is, like their skills are probably more suited to somewhere else. So for you, what you did when you were working in the early days, your expertise was in distributed systems. So you were helping those machine learning teams with your distributed systems knowledge, not necessarily working on specifically on the machine learning stuff. But you said like you learned it over time by being in the team. And that's a very like good mindset to have and a very clear path to basically going on that journey and establishing yourself as an ML engineer. What are some like tactical advices you have? Like, if you're in that situation or you have that opportunity, how could you move towards like that dream of being an ML engineer?
Again, very great and relevant and topical question. I get that very often from team members who are trying to make this transition, from friends. So this is, I feel like, on top of many people's mind. So I think the hard part of the transition is that first, first and foremost, you shouldn't be in it just because I think sometimes the motivation that I hear are, okay, I'll get a better salary or whatnot, or this is the hard thing and this is where I ought to be, which can be part of the motivation, but that can't be the be all. Uh, right. So what that means is if those are not your motivations, then it has to be something more internally driven, which is like curiosity, that you're intrigued by just what goes on. How is all this happening? Right. And so you have to be super intrigued. Then you have to bring your existing skill set to the table, which can be harder for, let's say, if you're just graduating from school. Then I'd say, yeah, I still feel I talk to a lot of those people and they're like, okay, I want to get in the space, but there are not many teams doing this. Even if you go to a company like Pinterest or Twitter, not everyone is doing the same thing. You still have to build a lot of other things. Um, so take the opportunity, whatever you get, go in with a curious mindset. Then over time, you can get to the right teams, let's say, but then hone your skill outside of just AI or machine learning first as a software engineer. Like, can you code? Or if you're really into it, then maybe pursue an academic path for longer, which will get you directly into these teams. No one will say no to hiring a PhD in machine learning in one of these teams, right? So, uh, so that's the long, boring path. But then, if you were to not, and not a lot of people are up, myself included, so you would then need to have some other strengths or be very into building and learning at the same time from the people who know it, right? So that's on the job learning. That in this field, I feel beyond the theoreticals, there's a huge part of what has worked, what doesn't work, what are the pitfalls that you can only get while you're in the field and done it multiple times in multiple scenarios, right? Because challenges for each, even if you're building a recommendation system for a video versus a tweet for a pin, just even if it's a recommendation system, the context changes and the solutions you would build also changes in that. right? So that's kind of other piece of it. Um, I think I lost some chain of thought there, but coming back to it, if you're curious and you have something to give to the team, uh, uh, then I think you're set, but then you have to stick with it for a while. I think the other day, just actually a couple days back, I was talking to a colleague, someone who was on my team from a systems background. He wanted to try machine learning. He went into the team. I think 6, 8 months later, he is not feeling good and looking to go back because there's also the mindset of pure systems or software engineering is a very deterministic play in some sense, wherein, okay, you have a spec, you're building a system to that spec. And as long as you've done that and it's working, you ship it. Right. That's not how it works. If you're purely an ML engineer, you have to have an hypothesis. And hypothesis by the very definition means it might or might not ship once you try that. So there's more science to it. I hesitate by calling it science, but those components would than pure software engineering. So a lot of times you'll not ship something. Right. So what that means is if you're the person who is coming up with this hypothesis being the first time in this area, you're likely to fail. So you have to have the right support system in those teams who are telling you what are the right bets to make, right? So you can stay with that for a while because you shouldn't be. So if you are going into a hedge fund or starting to pick stocks from day one, don't, bet the house on day one. Right? You have to have the right support system, someone telling you if you were to bet the house, where to bet it. So it's like you're betting your career, have the right support system in those teams. Don't be a kind of a loner in that space. So I think that's one mindset shift. Then you get to stick with it for a good 3 to 5 years at a minimum. And the third thing I'll say is you have to do a lot of work outside of what you're building on your job. Because there are a lot of basic foundation theoretical, thing that this is built on top of. You have to know that. And you have to stay on top of the industry. That's another challenge with this field that if you learn something today and you're just totally not bothered about where the industry is moving, 3, 4 years down the lane, you'll be obsolete again.
So Abhishek, how are you keeping yourself up to date? Like, were you reading papers? Were you taking those ideas and implementing in Python? Like, what are the specifics there?
So yeah, so for me, what works more of is I need to understand everything. So I have that internal desire to do that. So I would all the terms that would be thrown at me, which I have had no clue, which have kind of started to go down with time, I would keep taking notes of all those terms. So I would make it a point that I'm visiting all of them and trying to make a connect with them. So that was kind of more of a bottoms up approach. A top down approach was I started taking a lot of the foundational courses in my, outside my job. So then I understand, starting to build it from just the foundations. So I had to do both for a very long time. Uh, and most of these things wouldn't stick the first time either because, you're missing some of the foundations. What are you going to do if you start in the third pro straight away? You just don't know the one and two. You'll not understand the third thing on day one. So you need to keep stick with that. You basically start to create a tree where you're, more and more you need to learn on the foundations to start understanding what someone said on the third floor really. So that's what I meant by sticking with it. Good 3 to 5 years. So on the job, you're getting the practical knowledge. Outside of it, hopefully you're doing the extra work to really understand the space and the foundations behind it in this time. And all this while, hopefully you are a good builder. And so you're providing that value to the team. So the challenge though becomes that even the whole infra space has, everything is evolving. You got to focus at one pace at one time.
We're coming up on time, and I want to make sure we get to something that you alluded to before we started recording. You mentioned you've been thinking a lot about how your own um, perspective on recommendation systems has been shaped over time. And in this episode, we talked a lot about how recommendation systems have technically transformed over time. But we'd love to hear how your own thinking has.
Yeah. So I think as I was reflecting back on just this morning, I was surprised myself how this has changed. if you were to ask me this question 3 years back or so, I would still be very technical and be very kind of attracted by the latest and greatest buzzwords in the space. But stepping back, having being at Twitter, seeing some of the internal debates, and then now being outside of it, seeing the development at Twitter from in the last 3 4 years, but not just Twitter, also a lot of the things that have come out in the open with Meta is that I think technology is all good and great. There's a lot of intrigue in that, but at the end of it, the societal impact of the systems that these products enable and what the end product of all that is needs to be very top of mind for everyone who's building this, which gets lost, which I totally understand as engineers. You are really just into the building part and not thinking of the bigger societal impact of it. And if I were to click one layer down, if I talked about optimizing for business objective. Now, if you think of it, it's you are incentivizing your models for more engagement in some form or another in most of these places, right? And then what that will often mean, if you're not careful enough, is that you are just feeding more and more of the same knowledge bubbles or political bubbles or whatnot to the people to get them hooked. But this is not to say that that's the only way. If you're kind of considered enough, you'll find other ways. And now I feel like a lot of the industry has realized that and they're trying to move into that direction and be more considerate. You have to think outside of that because you can continue working for 5 10 years and just continue to hit on engagement. That'll be all good. But then you'll realize you have created a very kind of uh, siloed society or a very fragmented society who are so stubborn in their views they haven't interacted with anyone else because this physical kind of interactions are getting reduced day and day and you're just on these networks feeding yourself the content that you're most comfortable with so you'll continue doing that now what's the solution to that like I think one approach which Elon has taken in is that, you go in with a very fundamental principle in there that, okay, freedom of speech is important. So, barring some limitations which are provided by the law and everything else goes. But then the platform might, reduce the distribution of things that are I don't know, inducing violence or whatnot, but everything else goes. And then the interesting approach, I think, like community notes and all of that to balance that off as well. Either you do that or while you're building those systems, you have to be very considerate to not put people in their bubbles. Right. Yeah. So I feel like that's the biggest challenge. And being at Pinterest, we don't deal with that a lot because we are in the art of inspiring people. It's much easier, much more fun thing to do. Right. And people are really happy to be in their silos and that, you can be in your creative space and be very good, be actually incremental to the society and not be harmful in any concrete ways. So while we still have there's still challenges. So the other part is I talked about political and all of that, but there are even in these systems there can be bad actors, right? So it's kind of a space like security where there are bad actors trying to do weird things uh, that you don't know exist out there, and they can be just even in thousands. They can be a very niche population, but the more advanced your systems are going, they'll latch up onto even those niches and try to make the platform the best use for those thousands people. But you don't know that these thousands exist. The moment you know, you'll go kill it. But like, how do you know ahead of time? So this is kind of a cat and a mouse kind of a game, the way the security game is. And so that's another challenge. But then do consistently building the tooling and when you're creating these platforms, keeping that in mind that when that happens, can I just toggle a switch the moment I understand one of these bad actors, can I take all of them out in a go? Right. So that's another kind of space that's again more related to the theme of societal impact of building subsystems.
We really believe that software moves or progress moves at the speed of software development. So it's really nice how thoughtful you are being here. And I love we're in the business of inspiring people. Like that's so true. Just is such a positive place on the web. We're about at time. Erdafa, do you want to close us out with your number one question?
Yeah, this is my favorite question. Are there any fun books, podcasts, or people you want to give a shout out to, or that has influenced you, inspired you?
Starting from people, I think so. It was Steve Jobs when I was in school. I was further from him being from him as a personality, which is much easier these days with people like Elon. They brought a different dynamic to this. But both these people, Elon and Steve, I think just for how big they can think and how repeatedly they can make that big thinking come to life. I think that's a very hard and underappreciated thing. You can think, dream, whatever, but bringing things to life is hard. Now, knowing the other side of them, later on that, they come with some personality things, but I guess that's what you're going to live with when you're so obsessed with getting your dreams get them to life. So I think world can do with more of those people, and no one would mind the more Twitter antics that Alan brings if there are more Allens with their own Twitter antics. So I'm in some ways inspired with them, not in all ways. Then I guess podcasts that I've been recently into, I'm really into Masters of Scale from Reid Hoffman. I think just the nuance in the discussions that he's able to bring up is amazing, and the breadth of people he is able to bring in is amazing. And the production value never hurts. I think the production value of that podcast is really off the charts than anything else I've ever seen. Talking about books, yeah, lately I'm latched on to Nicholas Taleb. I think he's one of the provocative thinkers out there. So in the category of really provocative thinkers, recently I read last year Anti-Fragile. He usually writes very heavy books, but that Anti-Fragile is probably the one book that I've come across that would question everything that I've kind of assumed to be true as an axiom over all these years of living. And he does it very convincingly so. Right? Just think that you assume about the world, how the world works, and you take that for it. He really tries to convince you that most of these things are just dogmas, and the way it works is very different. I feel like that's a very mindset shifting book. It probably took me good 6-8 months to get through it because it's really, really heavy. But I feel like that was one of the best books I've read recently. Then I think there's this other category of structured thinkers in my mind, which are like very out there. They know how they model the world around. And just by the fact that they've seen so much and done so much, they have so much data coming in. So their machine learning models, so to speak, are very kind of evolved in some sense. The people I put there is like Ray Dalio, and he's very actively trying to teach the world what he has learned and what kind of, he's this extreme of, he's trying to model everything in the world in his brain. And even if you see how he's read about the book, in the book Principles, about how he used to run Bridgewaters, it's like pretty insane. He's trying to make a computer, not a company, and like trying to model everything into some sort of rules that people can go to, and it will always come up with the right answer somehow. So I think that's pretty insane. Then Paul Graham is another one. He's not writing books, but like just the essays that he writes, just tries to bring together so much that he has experienced and seen in a very structured and methodical way. Yeah, that's pretty it. On one last thing I'll add here is on I think the philosophical or the spiritual axis of things. I've gotten into reading the Gita the last couple of years. The text itself is amazing. I don't think I've seen anything that's so evolved on it, how it thinks about the world. And then there are a lot of call it translations, call it interpretation. I think Swami Vivekananda, I'm not sure if you heard of that. he had a lot of his interpretations on that. So I'm into it as well.
Like an amazing recommendation system. You haven't failed us, Abhishek.
Hey, where can people follow you online and follow what you're learning and doing and building?
Yeah, Twitter, Abhishek Tayal. You can just go look for it and find me.
Amazing. Thank you so much for coming on. This was so fun.
I didn't know I'd speak that much, but it was fun.
That's how podcasts.
Yeah, thank you so much, Abhishek. We learned a lot. This is basically like not only what's out there and what's really interesting, but also a very important history lesson on like how things have evolved in terms of machine learning recommendation systems. So our listeners are gonna love this. Thank you so much.
Awesome. I hope so. Yeah, really had a good time. Thank you for having me.